This video covers the introduction to sequences, so maybe note 16.3, but a sequence is a list of numbers or objects that are in a special order. So we're going to look at three different types of sequences that you could have, and then later this unit we're going to focus on some more sequences. So in example 1, we have regular polygons below that form a pattern. They give us the three different polygons and the perimeters of each. And part A asks us to write an expression that can be used to determine the perimeter of the nth figure. So we're going to make a chart. That's the figure number. So figures 1, 2, and 3. The first figure, second figure, third figure. And then compare it to the perimeters. So the perimeters of each are 6, 12, and 20 respectively. So we're going to put this into stat edit. Remember, if there's something in there, you can go up, select the list, and clear it out. Oops, sorry. So I want to clear it out. So my figures are 1, 2, and 3. And then the perimeters are 6, 12, and 20. So I'm going to run my StatCalc 4. Before I do that, I'm going to check that my diagnostic is on. We talked about this in the regressions day. So mode, scroll up, so that stat diagnostics is on. So this little thing needs to be on. If it's not, go over there and click enter. So when I do StatCalc 4, my R squared value is 0.993, so it could be linear. I'm going to do StatCalc 5 to see if it's quadratic, and it is. This one has an R squared value of 1, so my expression is 1x squared plus 3x plus 2. And if I wanted to run exponential StatCalc 0 just to make sure I can see my R squared value is not a perfect 1. Then to find the perimeter of the nth figure, we're going to let n or x equal 7. So I can either plug this into y equals, or I can just type it in. But I can plug this in, so x squared plus 3x plus 2. Go to my table, and when n is 7, the perimeter is 72 inches. Example 2, we're given a sequence in which a of 1 equals 3, a of 5 equals 19, and a to the n is 136. What is n? So first, I need to figure out what sequence is happening here. So I'm going to make a chart basically with little number and big number. So in the first one, a to the 1 is 3, a to the 5 is 19, and we'll talk more about these little things tomorrow, or on the 16.3. Nope, 16.4. So in StatCalc, I'm going to plug these in, see which regression works best. So my little numbers are 1 and 5. My big numbers are 3 and 19. So I'm going to run StatCalc 4. And I get an R squared value of 1. So that means this sequence is going to be linear, and I'm going to have a 4x minus 1. Now they want to know what x is when y is 163, because remember we put the big numbers in the y column. So I'm going to go back to y equals and plug this in, 4x minus 1. Go to my table and follow along on the y's until I get to 163. You could also work backwards to solve if you wanted. But 163 is where x equals 41. So if you wanted to work backwards, you would say 163 equals 4x minus 1, add 1 to both sides, and then divide by 4. Okay, so that's just another way to do this same thing we just did. Example 3, Harold is starting a new workout program in which each day he will complete 4 more push-ups than the day before. If he starts with 5 push-ups on the first day, how many push-ups will he do on the 12th? So let's let x equal days and y equal push-ups. On the first day, he said he was going to do 5. He will complete 4 more each day. So the second day, he should do 9. I'm going to put this into stat edit and see if I can find a regression for it. So StatCalc 4. My r squared value here is 1, so I will let y equal 4x plus 1. And then they want to know on the 12th day what would happen. So I have 4x plus 1. I'm going to go to the table and look for where x is 12. And when x is 12, y is 49. Alternatively, you could have filled out this chart all the way till you get to 12 and then see how many push-ups you had there as well.